All right, let's jump right into this. Today, we're taking a highly strategic, deep dive into the Cambridge Information Technology Syllabus 9626. Specifically, we're looking at Section 4.1. Now look, approaching an exam isn't just about memorizing a bunch of textbook facts, right? It's a game of strategy. I really want you to start thinking about your exam approach like a chess grandmaster. A grandmaster doesn't just stare at the board in front of them. They're constantly anticipating their opponent's next mental move. And in your case, the opponent is the assessment framework itself. So we are going to learn exactly how to anticipate what the examiner is looking for when it comes to arithmetic operators.
So here's our roadmap for today. We'll be hitting the challenge of this section, the core principles of the theory, a tactical procedural framework, critical analysis techniques, and finally, those top examiner warnings. Let's get to it.
Section 1. The challenge. Now, Section 4.1 covers arithmetic operators. We're talking about your basics: addition, subtraction, multiplication, division, and exponentiation. You know, the plus, minus, asterisk, forward slash, and the caret symbol. But here is the massive trap. Mastering this section is absolutely not just about basic math. If you go in treating this like a simple middle school math quiz, you are going to lose out on major marks. This section is fundamentally about systematic analysis. It's about how you use these tools to process data, evaluate outcomes, and actually demonstrate higher-order thinking within an IT context.
To really understand why this is so critical, we have to look at the 9626 syllabus code data. When we dig into the Cambridge Principal Examiner reports for this specific IT syllabus, a really glaring trend pops up. The reports consistently flag this exact section, 4.1 arithmetic operators, as literally one of the most misunderstood areas by candidates. It's crazy. Students see a plus sign or a multiplication asterisk, they think, oh, easy, and they completely underestimate the complexity of what the question is actually asking them to do.
Which brings us to a huge question that the senior examiners themselves are asking. Why do students find evaluating evidence and drawing conclusions so incredibly hard in this section? Okay, let's dive into this. The struggle mostly happens because students are trying to apply rote memorization to a task that demands deep cognitive processing. When you're asked to use arithmetic operators, you aren't just calculating a total. You're being asked to evaluate the evidence provided in the scenario and then draw logical, business-appropriate conclusions from those numbers.
Moving on to Section 2. Core principles, focusing on theory and cognitive domains. The whole conceptual framework here draws on established principles of evidence-based reasoning. You really need to understand the theoretical architecture that the examiners are actually using to grade you. Their academic benchmarks require logical, structured reasoning. The assessment framework explicitly prioritizes analytical depth over superficial breadth. Simply put, they do not want a shallow list of every operator you know. They want a deep, reasoned explanation of exactly why a specific calculation matters to the given scenario.
Look at how the assessment objectives target three very distinct cognitive domains: knowledge and understanding, application, and analysis. You absolutely cannot hit the top mark bands by only showing knowledge, which is just, knowing what an asterisk does. You've got to move into application, which is using it correctly, and then push right into analysis. Hitting these higher cognitive domains requires precise definitions, a solid grasp of causal relationships, and logical reasoning. You have to prove to the examiner that you understand why changing a single variable using an arithmetic operator ends up impacting the entire data model.
The examiner reports give us an incredible piece of insider insight here. They state, candidates referencing cross-topic connections achieve significantly higher marks. And wow, this just brilliantly illustrates the theoretical architecture of the syllabus. Integrating 4.1 concepts with other areas of the syllabus acts like a literal cheat code for securing top marks. If you can show how an arithmetic operator calculation in a spreadsheet actually affects data validation or how it relates to a much larger database structure, boom, you are instantly demonstrating the exact analytical depth that examiners are desperate to see.
Section 3. The tactical procedural framework. All right, now that we've got the theory down, let's talk execution. This is your technical methodology. We're going to break down exactly how to tackle complex past paper questions under the pressure of exam conditions, making sure you hit those higher cognitive domains we just talked about.
Here is your golden rule. We call it the method mark strategy. The absolute most crucial point to remember is that examiners award marks for the process, not just your final answer. Practical application in 4.1 is all about demonstrating professional skills. That means applying the correct formats, using the appropriate terminology, and evaluating performance.
If you just jot down a final number after doing a really complex calculation in your head, but you don't show the explicit arithmetic operators and formulas you use to get there, you are just throwing away easily attainable marks. Don't do it. So, to guarantee you get every single one of those method marks, follow these 5 essential steps. Step 1. Deconstruct the question to understand the actual context. Step 2. Extract the relevant data. Step 3. Select your analytical framework. Step 4. Execute with super clear notation. And Step 5. Present your findings using the correct terminology. Now, extracting that data properly in Step 2 is the foundation for literally everything else, which perfectly leads us to
Section 4. Critical Analysis and Data Interpretation. In 9626, your data interpretation skills are absolutely critical. You're going to frequently be required to extract numbers and context from really long texts and complex tables. Your ability to interpret the relationships between that data, apply your arithmetic operators, and then draw solid evidence-based conclusions, that is exactly what separates a passing grade from a top-tier grade.
To hit those absolute highest marks, you've got to engage in what the framework calls evaluative thinking. Top-scoring candidates demonstrate this by questioning assumptions, considering different perspectives, evaluating alternatives, and ultimately justifying their decisions with hard evidence. The assessment framework basically has 3 levels: descriptive, analytical, and finally, evaluative. If you're just describing the math, you're stuck at the bottom. But if you're comparing approaches and offering justified recommendations based on your calculations, now you're operating at the evaluative level. That's where you want to be.
A major part of this evaluative process is comparative analysis. Now, what's really interesting here is that it requires looking at both sides of the coin. It's not enough to just point out similarities. You've got to identify the similarities and the differences. You need to be using comparative connectives in your answers, words like whereas, however, or in contrast. And you must support each comparison with actual evidence drawn from your arithmetic analysis. This is exactly how you draw meaningful conclusions about relative importance, rather than just listing isolated facts.
Section 5. Top Examiner Warnings. Okay, we've talked a lot about what to do. Now we really need to look at what absolutely not to do. This is your insider's look at the most common pitfalls, pulled directly from the warnings in the principal examiner reports. The examiners have highlighted that there are exactly 3 critical mistakes that students consistently make year after year when handling arithmetic operators in the exam room. If you can simply train yourself to avoid these 3 specific things, you are already putting yourself way ahead of the curve.
So here are those 3 warnings. First, answers are often just way too vague. Like we discussed, simply knowing the symbols isn't enough. Examiners want specific, detailed process steps. Second, students completely forget to check their format and presentation. Remember the method mark strategy we talked about. You need clear notation and professional presentation. And third, and honestly, this is probably the most fatal one, answers are not specific to the context given. Let's look at that last one closer. The classic fatal mistake in 9626 is giving a generic, superficial answer instead of a specific, context-driven one. Look, if the exam question is about calculating payroll for a logistics company using arithmetic operators, your answer absolutely must reference that logistics company's specific data. Always, always link every single analytical point back to the given scenario. That is how you secure those top marks.
Now, under intense exam pressure, it's super easy to just blank and forget these procedural frameworks. So a highly effective tactic to avoid those common traps is a memory hack. Use a visual story method to encode the 4-1 concepts. Just create a mental narrative for the operators. Maybe the plus sign is literally adding cargo to a truck, and the division sign is physically splitting a budget among different departments. Visualizing the operators in real-world contexts forces your brain to remember the application and the analytical depth required rather than just seeing abstract symbols on a page.
And that brings us to the end of our explainer. We've decoded the strategy, outlined the procedural framework, and revealed the examiner's top warnings. The board is officially set. So, I'm going to leave you with this final thought. When you sit down for that exam, are you going to rely on superficial facts and risk losing all those method marks? Or will you use the method mark strategy to anticipate the examiner's next mental move? Master the process, justify your evidence, and go conquer that exam. Thanks so much for joining me, and keep learning.